Good afternoon, everybody. Thank you so much for joining us. Let's talk about how you investigate operational issues faster with AI. So these days, everyone's talking about AI for many different reasons. But AI can actually help you get to the root cause of issues quicker and optimize your operations. So today, Jared, Wei, and I are going to show you how AIOps and CloudWatch can do just that. But first, let's start about some of the challenges that we are hoping to overcome. My name is Anya De Velta. I'm a solutions architect here at AWS, but for many years before then, I was in operations. So this is a little story of when I worked for a different company as an SRE, of reactive monitoring, and I really hope that this resonates with you. Let me know if it does. So basically, I came into the office one day, and there was this blissful ignorance. I'm going to get the project work done today. No incidents, right? I'm going to get through this backlog today. And then an alarm came in, and I was really, really confused. There's been no changes, no deployments. Why is there a problem? So time starts passing by. Social media is lighting up like a Christmas tree. My service received about between 2,000 and 4,000 requests per second, and the requests were tailing off. They weren't off, they were just tailing off. And I didn't have a clue why this was happening. And of course, then my manager turns up and says, Anya, can you jump on the incident bridge? Anya, what's wrong? Anya, when are you going to fix this? And I'm still trying to work out what's happening, let alone tell him what's wrong. So at the time, we were using a different tool for tracing, so I was looking at that tool. We're using 2 different tools for metrics. And then we decided that my application was sending too much log data to our log solution, so somebody had this clever idea that we're just not going to do that. So I was attempting to tail log files on an auto-scaling group of 8 instances all at the same time. What could go wrong? Of course, I couldn't tell what was happening. Time started still going on. The front-end dev joined me. We're looking, and we just don't have a clue what's wrong. So there comes the false hope, right? It was a rogue permission last time. Maybe we need to try this. So we were implementing lots of fixes that just weren't solving the problem. By that time, we had the client developer with us. He couldn't see what was going on. So then came my favorite part, the desperation. Hands up if anybody ever randomly started rebooting stuff just in case it was going to fix the problem. Yay, I'm glad it's not just me. So we decided to reboot our RDS cluster for some reason, and that didn't fix the issue either. But then eventually, the client dev worked out that the clients actually redirect to grab a token that's long-lived. It actually lives for 12 months. And we changed the endpoint, and we were giving the client the wrong endpoint. So that's why they were tailing off, because they couldn't get back in. So actually, once we knew what the problem was, we felt this enlightenment. And actually, the next part was really quick, because we knew how to apply the fix and how to QA the fix. So that was cool. So back to our blissful ignorance we went. But the thing is, issues are always going to happen, and these unexpected things are always going to happen. But the aim of having a good strategy, using the right tools, and using AIOps is to make that circle as quick as possible and hopefully cut out those feelings like stress and desperation out of your life. So with that in mind, the plan for today is we're going to talk to you about AIOps and some of the best practices that you're going to need to get the best out of those AI tools. I'm then going to cover a couple of the existing tools that have been around for a while that you can use to help you. And then Wei's going to tell you about some of the new AIOps features on AWS that have just landed. Jared's then going to do a demo for us of those new tools, and then we're going to wrap up. So let's get started. So AIOps, it's not a magical solution, and it's not going to solve all of your problems, for now anyway. Instead, it's a set of algorithms and tools that use AI and machine learning and apply best practices so that you can leverage machines at what they do best, which is churning huge amounts of data or recognizing patterns, so then the humans can do what we do best, which is that higher order reasoning. But to do that, you're going to need to have some prerequisites to get the most out of it. Because no algorithm, machine, or human will be able to detect if there are any issues in your system or reason about the performance of your system if the necessary signals are not in place. So, in terms of AI and ML options or AIOps, you have options. So you could always do it yourself, which is train your own models and train them on the data that you have, which is for specific use cases, maybe that's what you need to do. Or you can use some maybe existing services like using Amazon Comprehend to run natural language processing over some data. But not many people tend to do that because that still requires a lot of effort. Or you could use services that already have built-in AI ML and then leverage them. But again, you're going to need some prerequisites and some foundations to get the most out of them, and we're going to cover them. So, of course, in terms of effort, if you want to do it yourself, you're going to have to train your models, tune your models, do all the kind of data prep yourself. Even with using those kind of managed services, there's still going to have to be some formatting and effort required. Or, again, you can use the services on the right-hand side of the screen, but they're going to work better if you've implemented some foundations. So I'm just going to cover them in a couple of slides now. So these are those best practices. So in order to observe your components, you're going to need to instrument them. And that means writing code. And instrumentation is one of the key prerequisites for getting the most out of those AI-assisted tools. So that's stuff like using standardized libraries so that your application code and your dependencies can interoperate. They can use the same monitoring tools, the same data structures, the same conventions. Or it's stuff like using open telemetry to standardize the way that you collect your telemetry. You're also going to need to understand the context of the data. And to do that, you need to use conventions so that you can understand which service and which service operation the telemetry is being collected for example. You also need to remember that to use standardized metrics for those service operations, using things like errors and latency and keeping them consistent. That's really, really important. You're going to have to make sure that you can instrument your application so that you can co-locate and correlate your information so you can, again, understand that context and you can search which host is experiencing issues and correlate that information together. You could also use things like embedded metric format specification. So basically, you would do that as you ingesting your log file. You could tell CloudWatch Logs to derive some metrics for you. Then you could create dashboards and alarms from there. But the original context will still be in the log data, so you'll be able to tell which customers having issues or which host is having issues as well. And you're going to have to observe from multiple perspectives. It's that outside-in observability and inside-out observability. So it's things like, for inside-out, is observing the infrastructure components or the individual service. But from outside-in, it's measuring the dependencies from the client standpoint and observing dependencies from the client standpoint. Because if I did that in the example that I used earlier, I would have probably got to the root cause much quicker because I would have known that my clients can't get to the token service. And of course, it's always really important that you observe the experience that whatever users of that system are having. So remember to implement things like real user monitoring or synthetic canaries to observe that experience. So once you have these best practices, one of the managed tools that you can use that has existed for a while is CloudWatch Metric Anomaly Detection. So that's backed by ML, but there's no need for you to train your models. You turn it on, it trains on the past 2 weeks of data if it's available, and it creates this anomaly band for you that you can then visualize or you can alarm on. And it works on vendor metrics, custom metrics, and also metric math. So let's consider some considerations for it. So basically, first thing about the right metric. It will work on vendor metrics, but do you want anomaly detection on CPU? What information is that going to give you? Have a think about it. So in my example here, I'm using embedded metric format specification. Imagine I am monitoring a website that allows users to adopt cats, dogs, or rabbits. So actually, these adoptions matter to me. So I'm using embedded metric format to extract that information from my log data. And then once I have this metric, I'm actually also going to add up all the cat, dog, and rabbit adoptions because I want to know one number. So I'm going to use metric math over the top of it. And then I'm going to create the anomaly visualization over it. So it's important to note that the ML model is specific to that metric and that statistics. So if I'm doing this for the average statistic for that metric, that's what it's specific to. If I wanted one for example, the sum, I'd create a second model as well. So things you need to think about there in terms of best practices. Think about standard deviation. So what does that mean? It just basically means how wide you want that band to be, how many points away from the middle you want to be. And you can actually adjust that. So that's the second kind of dimension on the anomaly detection band. So the higher the number, the wider the band. So think about that. Also, the model works over seasonal data. And the seasonality changes could be hourly, daily, weekly, and they could be trending upwards, downwards, or have flat patterns. But it's really recommended that you exclude specific time periods if there are unusual events happening at the same time. So you can do that as well. Then look out for sparse data. So the model has predictors that will attempt to improve metrics that are seasonal or spiky or sparse. But if you're going to be observing a really sparse metric, have a think about whether it's the right metric, or think about how you could maybe fill that data as well. And do you need to retrain your model? No, you don't. The anomaly detection model continuously evaluates whether it's the right model and makes adjustments to make sure that it's as accurate as possible. So no, you don't have to. So that's metrics. What about logs? So just a few last best practices for logs. So make sure you structure your log data. So for example, if you structure your data in the JSON format, CloudWatch Logs will automatically index it for you, which makes it easier for you to then search the data. But if it makes it easier for you, then those AI tools can parse your data easier as well. So that's really important as a prerequisite. Also, consistent naming of your log data or log groups as well. That's really important. And then words matter. How many times have you read like a log entry that made absolutely no sense to you? So if an outsider can't make sense of your log data, how can a Gen AI tool make sense of your log data? So actually, that meaningful data, I know it sounds obvious, but it's really important to make sure that it makes sense. So the tool that you can use for log data is CloudWatch Log Pattern Analysis. So basically, this allows you to search thousands of log groups across multiple accounts, and the machine learning behind the scenes will help you detect patterns in the log data. Will put the right information in front of you quicker. It will also determine any variable data in those patterns and let you count it. So will hopefully point you at the information much quicker, unless you want to be like me and tail log files on 8 instances at the same time. But it'll also help you answer what has changed. So with the compare mode, if you run it in compare mode, it'll actually pinpoint to you, is there a new pattern in that log data, or is there a decline in the pattern? So in a few clicks, again, it will help you determine if there's anything happening and hopefully help you resolve issues quicker. Or if you have business-critical applications and you don't want to wait till you search in the log data, you can use the CloudWatch Log Anomaly Detector, and you can create the anomaly detector on your log group, and then you can create alarms based on the severity. So we'll let you know if there's any anomalies found in the log data. And of course, you can also suppress any stuff that doesn't matter to you or filter it out as well. But after all that, there's still some challenges and extra work to help the machines and humans to get to the root cause quicker. How do you not know, or how do you know your unknown unknowns? That's really, really hard. So you're going to have to keep relearning or using patterns or using insight services. Maybe they'll surface some information that you didn't know existed. Now, learning dependencies is really, really hard for humans and for machines. So we already talked about the context and the best practices, but maybe using tools like application signals that will help you derive the dependencies and the relationships between resources. And then correlation is important, but just be careful about correlating backwards. So a friend of mine told me this story from many, many years ago. Apparently, ages ago, white bread was really, really expensive, and only rich people could afford it. So the correlation here was that rich people eat white bread. So does that mean that if you eat white bread, you're going to become rich? No, it doesn't. Actually, it will make you more poor because you can't afford to buy it to start with if you don't have the money. So this is the same for your metrics. Just be careful about flipping the correlation because it just might not work. And sometimes you might have causality without correlation as well. But with those challenges in mind, maybe there are some new tools that will help you overcome those challenges. So Wei is going to tell you all about the new stuff that's just landed. Thank you.
Thank you, Anya. My name is Wei. I lead product for AIOps at AWS. Thank you all very much for coming today. In addition to the existing features that Anya discussed and introduced, this week at re:Invent, we're bringing you a wide range of different AIOps capabilities to help you monitor and troubleshoot issues on your AWS workloads much better, much more effectively, and more efficiently. So you can really focus on innovation and get back to that blissful cat state. So specifically, there's a couple of things that I like to call out. One is the explore-related feature in CloudWatch. So this capability enables you to easily identify and examine other resources and telemetry that are related to a particular resource, telemetry, application, or you can even use tags in the key value pairs to drill down. We really think of this feature as part of the foundation for AIOps, because as Anya mentioned earlier, how well AI works really has a lot to do with the kind of data that it has access to and the kind of dependency relationships that it's aware of. This capability is really key to understanding the dependency relationship and to the AI's capability to know not just the correlation, but also to surface the causality. It automatically finds these relationships and uses various signals to put all of them conveniently in one place while you're exploring or monitoring any of your system. So, for example, you can start from a particular telemetry anywhere in the AWS console. In this example, we're using Lambda, and the side panel would open by clicking on the Explore-related button. It automatically identifies all the different resources, the logs, and the metrics for you to browse, and you can click on the deep links to take you directly to those consoles to examine them further. In most scenarios, if you already are using AWS services that have telemetry in CloudWatch, whether it's logs or metrics or traces or other things, or you have your CloudWatch agent upgraded to the latest version, in most scenarios, you don't have to do anything to set up or configure to be able to start using this capability. I'm also happy to introduce a new Amazon Q capability, operational investigations. This assistant is powered by generative AI, but it's not just generative AI. The AI is enhanced by years of internal Amazon operation knowledge. It also leverages an array of different non-generative AI, the more conventional machine learning techniques that we've developed over the years. And those algorithms and tools together, plus the generative AI, enables the assistant to surface correlation and identify causation for you and really supplement your investigation workflow. Using a telemetry signal as a starting point, it'll automatically scan a wide range of different data sources, such as CloudWatch logs, metrics, X-ray traces, CloudTrail, and AWS health events, so it can help you put everything in the same place and identify regardless where the issue really originated from. And building on top of the Explore-related capability that I mentioned earlier, Amazon Q will use both instrumented and configured dependency relationships, and it'll be able to infer them from different telemetry signals that sort of co-occur together. So for example, if you always have metrics from two different resources that always spike in quick succession or together, it'll be able to identify those for you as well. So we're using Lambda as an example again here, but similar to Explore-related, you can do that from a wide array of popular AWS services. You can also set up CloudWatch alarms to automatically start investigations with Slack and Teams notifications. So by the time your on-call engineer is starting to investigate the issue, they're already going to have all the different telemetry signals that are relevant in the same place, and the assistant is going to surface root cause hypotheses for them. For each of these hypotheses, Amazon Q will also propose next steps. These include Amazon System Manager automation runbooks that you can fill in the parameters and execute, or links to documentation and blog posts that explains to you potential fixes, best practices, and so on. Along with other features, these new capabilities really aim to simplify not just correlation, but also causality during your operations workflows. They help you automate the manual queries and lookups, quickly gather important information in one place, isolate where the issue is in your complex systems, and take action faster with less time loss. So next time when you're in the AWS console, look for this icon on the top right, give it a try, and let us know what you think. Back in my days as an on-call engineer, I had a very similar experience to Anya's. I'd get paged in the middle of the night, scramble to look for different information from 100 different places. And when I couldn't figure out what was going on, or I just had way too much data to process, I'd then page my coworkers in the middle of the night as well, even though I didn't know whether they were actually responsible or not. And as you can imagine, that did not create the most harmonious working relationships. Our vision for AIOps is one where you do a lot less of that, where the more mundane tasks, things like data gathering, dependency mapping, configuration, and different tools that you have to look up, are mostly handled and simplified by AI. So the humans can really focus on what humans do best, which is creative problem solving, innovating for your customers, and making strategy decisions to improve your systems so they work better and you don't have similar problems occurring again in the future. And we're just getting started. So on this journey, we really need your help. We want to hear from you, how to best solve your problems, and to enable you to do those things as well. But first, it's demo time. So I'll bring my colleague Jared up on the stage and demonstrate some of the features that we just talked about.
Let me grab some water first. Before I get started, I think I know the answer to this, but how many people in this room are operators? So you get paged to respond to issues for a service. Cool, me too. Hey everyone, my name is Jared Nance, and I'm a principal engineer at AWS. And I've been on call for a little over 10 years now, the last 6 years of which I've worked in CloudWatch. But before that, I worked in a handful of startup and enterprise-grade organizations building domain-specific monitoring solutions across manufacturing and healthcare industries. I use CloudWatch every day to debug applications as I build them, to troubleshoot incidents in real time, and for exploratory data analysis, where I'm trying to learn more about the performance of our services at runtime. So I live and breathe observability, and I'm very passionate about improving the tools we use every day to make us all more efficient. I'll cover this demo in 3 parts. First, I'm going to give some background about a sample application and incident. Then I'm going to show you how I can use Amazon Q to troubleshoot that incident. And finally, I'll show you how you can get started for yourself. In this story, I manage a service platform that enables veterinary clinics to manage their bookings, pet histories, and the general capabilities that these offices need. This is a multi-tenant application, which means that my service is processing requests from multiple clinics at any time, all in the same infrastructure. On screen, I'm showing the clinic portal. This is the UI that my customers, the clinics, use on a daily basis. They can sign in, they can see a list of their customers, manage their pets, and create bookings. Creating bookings or customer visits is a core operation for the clinic business. As a service provider, it's something that I need to keep up and available at all times. So let's take a look behind the scenes of this service and the incident that I'm going to respond to. Whenever a customer visits the pet clinic site, their request will go to an ALB, which will route their request to my front end, which is just a service running on EKS. That service will route the request to a backend microservice that's responsible for processing the specific operation that's needed. Each of these services has their own dependencies, whether it's storage or messaging or third-party systems like our payment processing system. And remember, this is a multi-tenant service where every tenant is an individual clinic. Now, this distributed architecture is nice for a few reasons. It allows us to compartmentalize complexity. It allows each service to deploy and scale independently. But with all of the benefits that service-oriented architectures bring, they also have additional challenges when it comes to monitoring and observability. Observability data may be scattered, and issues in one component may affect many components, making it difficult to localize the issue. Let's take a closer look at the data flow for when my customers book a visit, and let's walk through the sequence of events that are going to lead to our incident. Whenever a customer books a visit, their request will be routed to our front end, which then hands the request to our visit service for processing. The visit service will store the visit in the DynamoDB table. But today, something unusual is going to happen. One of our clinics is going to start driving a large number of requests to book visits. Maybe they have some technical issue on their side, or maybe there's an epidemic affecting a lot of animals. When that happens, my Dynamo table is going to start throttling the visit service. It's actively limiting the request rate because we've exceeded the capacity that we've assigned to the table. Specifically in this case, it's going to throttle the write traffic. So customers will be able to see that there are slots that they can book, but they won't actually be able to visit or book the visit. The visit service latency will start to increase, requests will start failing, and all of this will back pressure my customers. And so my customers will see their requests hang and ultimately fail. And now, across multiple clinics, owners are struggling to schedule urgent visits for their pets. Imagine it's Saturday morning, and a pet owner notices that their dog isn't eating. They're trying to book an urgent appointment through our system, but the booking keeps failing. Every minute they wait adds to their anxiety about their pet's health, and this is the real impact of our system's availability. Owners may seek care from other providers, the clinics will lose direct revenue from the specific visits that couldn't be booked, and all of this impacts my business and erodes the trust that my customers have in our ability to deliver the service that they need. Maybe this situation or some version of it is familiar to some of you. It has common elements with issues that I've encountered personally in the past. We have a distributed system where load and back pressure is impacting multiple components. We have a top contributor problem where the failure is being driven by a single customer or device. Needless to say, it's not a fun situation to find yourself in. So I'm going to put my operator hat on, and let's pretend that I've been paged in on an alarm for a metric on my front-end service here. At this point, all I know is that the availability for the book visit operation is impacted. Because of the criticality of this operation, it's really important for me to figure out what's causing the impact and get the system back into a stable state. So I need other signals the alarm doesn't tell me what the underlying issue is. So maybe I go looking at dashboards, maybe I start looking for logs, maybe I have a run book, but I'm now entering this kind of investigative mode. All the information I need is scattered. It's in different places, and I need to remember where to go and what tools to use. All of this can take a lot of time, and the longer it takes, the higher that pressure to get my service back online only increases. In this incident, there are 4 things that I need to understand. I need to understand that my front end is impacted by the visit service. I need to understand that the visit service is being throttled by DynamoDB, and that's what's driving the latency and errors. I also need to possess some understanding of how my table is configured and how Dynamo manages capacity, and that I'm being throttled because I'm consuming more than I provisioned for the table. And finally, I also need to understand that the increase in load is coming from a single customer. So let's see what my experience troubleshooting this issue can look like instead with Amazon Q. All right, the screen I'm showing now is the CloudWatch alarm that's fired due to the drop in availability. From my alarm history, From my alarm history, I can see that Amazon Q has already responded to the alarm and an investigation has been created. When I click on this link, I'll be taken to the investigation screen. In the middle of the screen, you're seeing what we call the feed. You can think of the feed as findings or facts about the investigation that I can collect as I'm building up observations and exploring the AWS console. I can include logs, metrics, traces, and other observations from more than 80 AWS service consoles. At the top of the screen, you'll see the analysis complete, which is the status of what Amazon Q is doing right now. In this case, it was able to complete its analysis before I even logged in because it was associated with a CloudWatch alarm. Now, the really cool part is here, when I click the suggestions panel. What I have here is, you can think of Amazon Q as a pair operator that's looking at the data in parallel and suggesting things that might be interesting. When Amazon Q makes an observation, it'll share it through the suggestions panel. As it makes more and more observations about the incident, it will combine these together to produce a hypothesis about the root cause. I've already applied a filter to only show those intermediate observations. Here we can see increase in network on my EC2 instances. We can see log queries that indicate DynamoDB throttling exceptions. We can see other network traffic increases across my clusters. And you know what's really cool about this? Instead of me having to hunt for data and look at dashboards or go find my log groups and start querying them, I have a single feed where I have metrics, logs, traces, and events all being presented to me and curated for me by Amazon Q. If I like a suggestion, I can accept it and add it to my findings. If I don't like a suggestion, I can discard it and remove it from my suggestion feed. But what if I don't know what these metrics mean? I can click on a tooltip and ask Amazon Q inline and have Amazon Q explain to me the meaning behind the metric, how it's measured, what units it has, so that I don't have to go query documentation or leave the console where I'm doing my investigation. The second type of suggestion you'll get from Amazon Q is what we call a hypothesis. A hypothesis takes all of those observations and presents a causal explanation for what caused the event. In this case, you can see that Amazon Q has identified that the DynamoDB table experienced throttling due to a sudden increase in write operations from a single customer. It identifies that the cascading impact across my different services all the way to the alarm. It gives me possible next steps for troubleshooting and mitigation. Now, remember, I'm new to this investigation, and I probably want some more evidence to back up this hypothesis. I can click Show Reasoning and see the specific evidence that Amazon Q has selected and used to derive this hypothesis. Here we have that increase in network traffic. We have my failing canaries. We have the drop in requests on DynamoDB. And here we have the contributor insights rule that identifies the single customer driving the traffic. And actually, before I go any further, who here knows about contributor insights and that capability we have in CloudWatch? No one? Okay, one. That's okay. You don't have to know about this. Amazon Q is going to use these capabilities of CloudWatch without you having to be aware of them. So at this point, I like this hypothesis, so I want to add it to my investigation. So at this point, we've successfully diagnosed the issue, and I need to move into mitigation. I have multiple options for mitigation, and this is where I, as an operator, need to apply the context and understanding of my own system to know what the right mitigation is. I could increase the provision capacity for the Dynamo table, which will allow the increased load to come through, but it will also increase my baseline costs. I might want to move to auto-scaling, but I'm in the middle of an incident, and I don't want to think about my auto-scaling configuration. I could also move to on-demand, which will allow me to dynamically scale, but it also increases the variability of my costs. I need to take these into consideration and apply my own judgment to decide what the right action is. But when we have identified some of those actions, Amazon Q will present them to you. Here, I have a runbook to increase provision capacity for my Dynamo table. In this case, I still don't know why this customer is driving the traffic, and I know that all of my tenants may be impacted. So I'm going to go ahead and use this to increase the capacity of my table while I work separately with the customer to understand what's driving the load and whether or not we should be throttling them or if the traffic is legitimate. I can view the AWS managed runbook, add the parameters, add the required parameters, so the table name. I know that read capacity is not impacted, so that's fine. I can use my metrics to determine what the correct write capacity is. So we'll go ahead and add that. I'll save that and then execute. When I execute the action will be added to my investigation for posterity. I can track the execution here, and when it completes, we would see that the alarm will recover, and we've now mitigated the incident successfully. My next steps might be to work with our customer care team to contact this clinic that's driving the load so that we can address the real root cause. Finally, I can close my investigation. Here we can see that action completed. I can close my investigation so that the next time the alarm goes off, it'll automatically trigger a new investigation. So we responded to an alarm that was triggered by a drop in availability of one of my services APIs. We were able to immediately review suggestions from Amazon Q, and those suggestions included simple observations as well as hypotheses about root cause. Amazon Q helped me identify short-term actions I could take to mitigate the issue, and now we've recovered, all without having to run a single query or hunt for data manually. In addition to the AWS console, I think many of our customers use Slack for their communications. I know the teams that I work with inside of Amazon, we all communicate through Slack. And so we thought it would be really cool if Amazon Q could also participate in those operations channels. Here, I'm showing an integration with Slack that shows that the investigation had opened from the alarm, which creates a thread, and I can see the specific metric that triggered the investigation. I also have a thread here with all of those intermediate observations and a thread that shows the hypotheses that Amazon Q has found. All right, so the next question is, this is pretty cool, right? So I'm sure you're wondering, how do you get started? There are kind of two categories of things that you need to do to actually start using Amazon Q. The first is what I call the essentials. You need to create an investigation group as the first step. And you can think of an investigation group as a container for your investigations that you can hang common configuration on, such as retention, encryption, and third-party integrations like Slack. You can also configure the permissions that Amazon Q will use when it's accessing your resources and querying your telemetry. Generally, we would recommend that you configure the same permissions for Amazon Q that you would configure for your own operators. Next, these are the things that you can do to maximize the performance and value you get from Amazon Q. Like Anya and Wei mentioned earlier, understanding your dependencies is incredibly important so that we're producing the right signals in the most efficient way possible. To do that, we would recommend that you turn on application signals. And if you're an EKS customer, you can do this through the EKS add-on with just a few clicks. You can also enable X-ray tracing and upgrade your CloudWatch and FluentBit agents so that you can take advantage of the latest capabilities. We also recommend that you are using enable CloudTrail, and many of our customers are already sending their CloudTrail data to CloudWatch logs. This enables us to detect changes in your resource configuration, which might be the causes of potential issues. And finally, we recommend that you configure Amazon Q on your alarms. It's not unusual, though, for you to have multiple alarms associated with a single component. And in those cases, just like with your ticketing systems, you don't want to create a bunch of different investigations all for the same issue. And for that, you can use composite alarms and hook your action to the composite alarm instead. So once you've done that setup, and actually once you've completed the essentials, you can actually try out a sample investigation so that you can get a better understanding for the experience and what we're trying to deliver. To get started on your creating investigations, Amazon Q Operational Investigations has many different entry points to meet you wherever you are. The example we walked through today was an auto-triggered investigation set up proactively as an action on a CloudWatch alarm. You can also just ask Q in chat, why did I get paged, and be guided on next steps. And finally, if I want to start an investigation from a spike on a dashboard, maybe I didn't have an alarm previously configured and I'm curious about what's driving that spike. Like Wei showed already, I can just highlight that graph from more than 80 AWS service consoles and create an investigation. And I'd like you to walk you through a live demo of that now too. Okay, so I'm on my weekly review dashboard for my front-end service. And we can see some drops in availability. And maybe this one looks a little bit different from the others. So maybe I want to investigate this one. I can click the ellipses on the widget and click Investigate and start a new investigation. I lost it, hang on. Here we go, sorry about that. I can give my investigation a title. And click Start Investigation to have Amazon Q start looking at that. Within a few seconds, you'll start to receive suggestions, those intermediate observations, and within a couple minutes, you'll start to receive those hypotheses. Now, I'm going to stick with the same story I had before, but I'm going to change something a little bit here. I'm not going to make you wait on it either, so I'm going to pull up one that I already ran. In this case, the drop in my book visit availability isn't caused by a change in traffic. In this case, someone on our team, it was me, put a resource policy on the Dynamo table that denied all traffic to the table. It's not a great move. Maybe I should implement better change control policies, but things happen. So let's see if Amazon Q is able to find that. We can go to the suggestions, and I can see the hypothesis that Amazon Q has found that identifies that the visit service experienced authorization errors when attempting to perform put item operations on the visit registration's Dynamo table, which ultimately triggered the alarm. I can click on Show Reasoning and look for that data. Here I can see a query that identifies that the user on my service wasn't authorized to perform put item. I can see those failed requests. And here's a really interesting thing. I can see the CloudTrail event that actually changed the resource policy on my Dynamo table, and I can deep link into CloudTrail to see what actually initiated that change. Here I can see that it was me. I was the person that broke our service. And I can even see the statement that denies the traffic to the table. All right. So that was pretty cool, I think. We were able to start an investigation from any dashboard across the AWS Service Console, and Amazon Q was able to identify a different root cause this time that was caused by a change in configuration, and was also able to pinpoint me to the specific change in API call that I made when I changed the policy. So I hope you enjoyed the demo, and with that, I'll hand it back to Wei to wrap us up.
All right, we're just bringing our cat friend back up again. Thank you again so much for patiently listening through the story and watching the demos. A couple things to take away with you. Again, starting with good foundations. Here's a QR code that you can scan that'll take you to the Observability Best Practices Guide, so you can implement those instrumentation, the different telemetry to give the best data to the AI assistant. Keep up to date and experiment. Follow our One Observability workshop that'll be continuously updated with the latest CloudWatch and other features. And lastly, check out the Amazon Q developer capability. You can try a sample investigation following the guide through the QR code. Thank you again so much. We're going to be hanging out just around the exit if you have any questions. Thank you again so much for your time.